Okay, so this mini lecture is going to look at how do charged particles behave in the presence of an electric field. So let's first remind ourselves what an electric field looks like for a point charge. And we're going to just use the example as a point charge to describe how charged particles move in that field. And then that can be extended to areas of constant electric field, like within things like a capacitor. So if we have a positive charge, and that charge is going to influence the space around it, causing an electric field. We know for a positive charge, the electric field lines point radially outward. So you can imagine this sort of starburst of electric field lines pointing outward from that positive charge. Now what happens if I bring another positive charge, a very tiny one that's not going to influence very much the electric field, so much smaller than this charge Q that's producing the electric field. If I bring a positive charge into this space, so here's my positive test charge. What will that positive test charge do in the presence of this other positive charge? Well, these positive charges are the same. They're likes, and we know that likes repel. And so the force that this charge feels from charge Q is in the repulsive direction, the outward direction. And it's outward along a line connecting those two charges. Well, that's the same line as a radial line of an electric field. And indeed, positive charges experience forces in the same direction as the electric field. If I were to put a positive charge here, well, those two charges would exert a repulsive force on one another. That's that direction for charge Q. So there's the force it feels, again, radially outward along that electric field line. Because positive charges experience forces in the same direction as an electric field, if I were to plop a charge there, it would experience that force. Force is a change in motion. It would start to move in the direction of the electric field lines. Okay, what if I have a negative charge, I get rid of my positive charges, and I put a tiny little negative charge in there. Again, not one that can influence the space very much. I mean, it still is gonna because it's a charged particle, but this is a much bigger particle, a much bigger strength of charge, and so it's huge influence over the electric field. The other one, too tiny to worry about. Well, if I put a negative charge, I'm going to put in the same spot as I put that positive charge. What kind of force does this negative charge feel by this positive charge Q? Well, it's an attractive force. That means it's towards along the line that connects those two charges. And so the force that charge Q feels is towards the positive charge. Well, that's opposite the field lines. Negative charges experience forces opposite the direction of the electric field. Does that work over here? Well, let's pop that negative charge over here. Again, it's an attractive force to charge Q, which is in the rightward direction. Again, opposite the field line at that location. And so if allowed to move, that charge would move in the direction opposite the electric field. It feels a force in the direction opposite. All right, so what if I change it up? What if I put a negative charge in space? And these aren't going to influence each other. Let's pretend that it doesn't exist. Does the same generalization hold true if I have a negative charge Q? Well, the electric field lines for a negative charge point inward. So if this is a point source, the electric field lines kind of point inward, kind of starburst inward. If I take a positive charge Q and I put it in the presence of this electric field, again, too small to really influence the field itself, well, a positive charge and a negative charge feel an attractive force along the line that connects them. And so the force that this positive charge feels due to this negative charge is indeed in the radial direction inward, the same direction as the electric field. So for a negative charge influencing the space, a positive charge will also experience the force in the same direction. Well, what about a negative charge? We'll put a negative charge down here. Well, negative charge and a negative charge repel each other. And so the force that this charge feels is in the downward direction. And again, that's opposite the direction of the electric field. So we can feel pretty good about this generalization of how charged particles behave in the presence of an electric field. They feel a force in the same direction as that field if the charge is positive. They feel a force in the opposite direction of that field if the charge is negative. All right, good job.